All right, so this is the rest of section 5.2. There isn't anything technically new. I'm going to do maybe 6 problems, 2 where the u's come out perfectly, 2's where you have to multiply to get the u's by an integer, and 2 that you have to multiply by a fraction, I think. And boy, that probably be close to 30 minutes. So let me start with just number 2. It's here. Parentheses with an exponent. I always, if I have a parentheses with an exponent that I can't comfortably clear, I rewrite the problem so that the parentheses with the exponent is written first. And that's the case here. That 5th power makes it so I can't try to clear it. In fact, when I wrote the key for this, there's like websites that will integrate. It can't really do this. I mean, it can do it, but not how the proper way. It does it by multiplying out the parentheses, which is not really what we're looking for here. So first step, I did it, wrote the parentheses with the exponent first. Now I'm going to let u be the inside of the parentheses. We have 2 essential choices for u's. If we have an e problem, u is the exponent of the e. If we have a parentheses with an exponent, u is the parentheses with the exponent. So now that I can rewrite the problem with the parentheses, x cubed minus 4, changed to a u. Don't really need the parentheses now, but I will need it at the end. So let me try to get rid of this. Whoa, I forgot the 3x squared. All of a sudden, this would be no good. So this should be the integral with or without the parentheses of u to the 5th, and then 3x squared dx. This is what I need to get rid of. I need to use this u and its derivative to get rid of that. How do I do it? Well, I find the derivative of that u. We'll say the derivative of u is du dx. The derivative of x cubed is 3x squared. The derivative of the constant minus 4 is 0. So the derivative of x cubed minus 4 is the 3x squared. That's a good thing, because that's exactly what I need is 3x squared. Multiply both sides by dx. That's going to give me du on the left side because the dx's will cancel, and 3x squared dx on the right side. At this point, either I have an exact match of what I need to replace with the x's, or I need to multiply by an integer or multiply by a fraction to make it an exact match. Because this is an exact match, I'm good. What can I do now? Now I'm going to do my replacement. So now that I have the problem with the knowledge of what the 3x squared dx needs to be replaced with, I'm going to take the problem, which is u to the 5th times 3x squared dx. That's my current state for the problem. And what am I going to make 3x squared dx? Well, 3x squared dx is equal to du. So this 3x squared dx, I'm going to replace it with exactly du. This is a good thing because I didn't have to multiply by an integer or multiply by a fraction. Really good place to be here. Now this is just a generic variable to an exponent. I'm going to add one to the exponent to integrate now using the power rule. So I add one to the exponent, multiply by a fraction that has 1 in the numerator and the new exponent in the denominator. Then I tack on a plus c. Almost done, but my answer can't have u's. My answer needs to have x's, and maybe it helps if I think of that u in a parentheses. What I'm going to do is use this x cubed minus 4 and change the u to x cubed minus 4, and I get my answer as 1/6 times the quantity x cubed minus 4 to the 6th plus c. Let me skip. I'm going to skip problem 4. It's not really any, let's just do it. What the heck? Let's do problem 4. So problem 4 has a parentheses with an exponent, and I don't know why I have the exponent of 5 so much, but I do. Doesn't matter what the exponent is. some reason 5 felt like the exponent I wanted to use, and that's just what happened for all these problems. So I rewrote the problem so that the parentheses with the exponent is first. Anytime I have a parentheses with an exponent that I don't want to clear, I need u substitution, and u, I always make the inside of the parentheses with the exponent. So in this case, u is going to be 4x squared plus 2x minus 7. I'm going to rewrite the problem so that the parentheses is changed to a u. Don't need the parentheses anymore, but it's nice to have it. I do need the dx that I neglected to write. So there's my writing the problem in a good order, getting the junk changed, the inside of the parentheses with the exponent changed to a u. Now let me do the derivative. I'll say du dx equals to the derivative of 4x squared. I go 2 times 4 is 8, lower the exponent by 1 and get an 8x. The derivative of 2x is just 2. The derivative of the minus 7 is 0. So the derivative of 4x squared plus 2x minus 7 is exactly 8x plus 2. That's a good thing because that's what I needed to match up with. I needed a dx as well, and I'm going to get that dx by multiplying both sides by dx. So I use the u and its derivative to get the rest of the problem so it doesn't have x's. What am I going to change? Well, this du is equal to exactly that 8x plus 2 dx. So now I can rewrite the problem as u to the 5th, and then for 8x plus 2 dx, just make it du. Now I'm going to integrate. I'm going to add 1 to the exponent, so my new exponent's going to be 6, multiply by a fraction that has 1 in the numerator and the new exponent in the denominator, tack on my plus c. To finish up the problem, I can't have the variable u. I need to change the u, put it back in a parentheses, and make the u into that. And so to go from, well, I don't have the answer on this sheet. So for my answer, I'm going to take basically the skeleton of my answer, replace the u with a parentheses, and inside the parentheses, what I let u equal, which is 4x squared plus 2x minus 7. Let's do an e problem. That's a friendly e problem. Let's do an uglier e problem. So let's skip 6 and go on to 8. Just don't think I need to do every problem in these because we did the warm-up half. So, in e problems, that's just not e to the x. I know I'm going to use u substitution. I write the e piece first. Just like I write the parentheses with the exponent first, I like writing the e piece first. Makes my substitution so much easier to follow. So after the e, I'm going to write the 6x squared plus 8x dx. That's a parentheses that doesn't have an exponent, so I'm not going to let the u be 6x squared plus 8x. If I had both an e and a parentheses with an exponent, that would be beyond the scope of our class, so we won't worry about that. So here I'm going to let u be the exponent of the e. We only have 2 choices for the u's. If we have an e, the u is the exponent for the e. If we have a parentheses with an exponent, the u is the inside of the parentheses with the exponent. We'll never have both. So now I can rewrite this problem with the exponent changed to a u, and I'm going to need to use the derivative of u to get rid of the 6x squared plus 8x dx. Either the derivative will match it perfectly, I'll have to multiply by an integer or multiply by a fraction. So let's find out. So I'm going to do the derivative of this. I'm going to go du dx equals to the derivative of 2x cubed is 6x squared. The derivative of 4x squared is 8x. The derivative of 3 is 0. It's basically an exact match. I'm not going to have to multiply by anything but the dx. Put parentheses on the right side when I multiply by that dx. This gives me du equals 6x squared plus 8x dx. So now this is going to change to that du. And I need that to happen. So now I get the integral of e to the u du. And e is its own integral. E to the x integrates to e to the x plus c. E to the u integrates to e to the u plus c. Always after I integrate, I need to get rid of the u. In this case, I'm going to change the u to that. And the exponent works like a parentheses, so when I do the substituting, I don't really need to create a parentheses like I can for the non-e problems. So that would be my answer. Let's move on and do some ones where I have to multiply, because it doesn't come out perfectly. And problem 14 is one of those. And I can tell by looking at it, and I also can tell because I set the problems up in groupings. The first 12, the u's come out perfectly. 13 through 24, you have to multiply by like a 2, 3, or 4, an integer. And then 25 through like 30, I have to multiply by a fraction. So 14, parentheses with an exponent. With that 5 again, I'm going to rewrite the problem so that the parentheses with the exponent is written first. And then the 15x squared and dx is going to be written afterwards. Anytime I have a parentheses with an exponent, 100% of the time I let u be the inside of the parentheses with the exponent. So I can rewrite this problem without the parentheses with a u. Should always write equals if something is equal to the line above it, and that's oddly equal to the line above it. So I need to get rid of a 15x squared dx using the derivative of the u. If I want to get lazy, I do this. I go du is 3x squared dx, and don't do the multiplication in my head, rather than writing du dx and then multiplying both sides by dx, because I know I'm going to do it. Why not just have it done and put the dx at the end of the right-hand side rather than doing the extra step? That's the way we usually do this. Now I try to match. I see 15x squared dx. I have 3x squared dx. Not good enough. How do I make it good enough? I'll multiply both sides by 5. When I multiply 5 du times 5, I just get 5 du. That's not so good. But 5 times 3x squared dx gives me 15x squared dx. Very good. So now this, I'm going to replace with 5 du. I'm going to write the problem as u to the 5th times 5 du, taking this 15x squared dx, changing it to what it's equal to in terms of u. This can be treated as a coefficient. I'm going to pass it through the integral and make this 5 times the integral of u to the 5th du. And now I'm going to integrate. I know that the new exponent is going to be 6. I'm going to add 1 to the exponent. So that means I have to multiply by 1/6 when I do the integrating. And bad things happen here because I have this fraction that doesn't cancel. I have to think of this as 5 over 1 times 1 over 6. Multiply the 5 times 1 and get 5. Multiply the 1 times 6 and get 6. Sneaking that parentheses in because I'm going to need it. My answer should never have a u in it. My answer should have what u equals to instead of the u. So for an answer, it's going to be 5/6, and then inside the parentheses that I'm going to create, an x cubed minus 4. Skipping around just because I don't want to do so I'm skipping problem 16 and 18, moving on to 20. I'm not going to do every single even numbered problem just because I don't think I have to. But if you're stuck, There's handwritten solutions to all of the homework problems. Some of them better, more readable than others. Writing on my iPad, legibility isn't always the best. So if you're having issues reading anything that I write, let me know and I can make an attempt to rewrite it. I actually think I'm going to pay one of my tutors to rewrite some of my stuff soon here, so that everything is more readable. I can kind of write when I'm lecturing with these markers so it's readable, but boy, on the iPad I really struggle. So, it's an E problem, so I wrote the E part first. Anytime with an E problem that's just not e to the x, I let u be the exponent of the e. So the steps are all written here. I'm just doing the steps without actually saying them, but if you needed the steps, you can read right through them. It'll tell you step by step what to do until you get to the point where you don't need the steps. Let me do the derivative. And instead of doing du dx, I'm going to put my dx on the right-hand side rather than multiplying both sides by dx. And I'm going to need a parentheses on this side because there's going to be two terms from the derivative. So rather than writing du dx and then multiplying by dx, I'm skipping the multiplying. The derivative of 2x cubed is 6x squared. The derivative of 4x squared is 8x. And the derivative of that 3 is 0. I'm trying to get rid of 18x squared plus 24x dx. I can only ever multiply by an integer or multiply by a fraction. And this is nice because this doesn't match perfectly, but it's easy to figure out what to multiply by, because 6 times 3 is 18. And 8 times 3 is 24. To make my match, I'm going to multiply both sides by 3. So I'm going to get on the left side 3 du. And now I'm going to multiply through the parentheses. I'm going to go 3 times 6x squared and get 18x squared. And then 3 times 8x and get plus 24x. Still have the dx. Good place to be now because this is exactly a perfect match. This and this have to match perfectly. Now I know what to replace that whole junk with. I'm going to replace it with 3 du. So I can rewrite the problem as e to the u, which I never even took the time to do yet. I should have written this as, this should be a u right here. Well, I rewrote the problem, but I forgot to do the u part. I should have, it doesn't matter. I should have said this is e to the u times 18x squared plus 24x dx. The truth is, when I'm doing this by myself, I skip so many steps, and this would be one that I just instinctively skip. I can do these all at once. Like I probably went from this to this without showing that. I probably would have done that. That's why I just instinctively did that. But I should have, if I'm being consistent with myself, change whatever the u is to that u, and then get rid of the x part. And I'm getting rid of the x part by making it a 3 du. Pass the 3 out front and get 3 times the integral of e to the u du. And this is the only kind of e I could integrate, just a naked e to the 1 of that variable power. And e's are the friendliest integrals. They integrate back to themselves. So this is going to be 3e to the u plus c. Need to change the u back to this mess. So for an answer, it's going to be 3e ugly exponent of 2x cubed plus 4x squared plus 3. And even though I'll forget it more often than not, the plus c goes on the end. This, we haven't done one in the second part of the video. Fractions like this we did right on the first part of the video. Let me do one right now. Problem 22, I have to think of this as having a parentheses with an exponent of 1 in the denominator. I can't do what I did in 5.1 and make two separate fractions up. You can only do that if the denominator has one term and the numerator has multiple terms. This is inverted. When the denominator has multiple terms, I can't just separate it into multiple fractions. I need to rewrite it with a negative exponent. I'm setting it up for that negative exponent by putting a parentheses with an exponent of 1. Now I can rewrite it with that negative exponent. I'm going to write 30 times 10x plus 3 to the negative 1 power dx. And when I have parentheses with exponents, it just helps me if I write that parentheses with an exponent first. Again, you might be able to skip steps and get to the answer, and that's a good thing if you can. So after the parentheses with the exponent, I needed a 30 dx. It's a parentheses with an exponent problem, so I always let u be the inside of that parentheses. So my u is going to be the 10x plus 3. That should allow me to write this as u to the negative 1. That tells me I'm going to get an ln. Negative 1 exponents give me ln's times 30 dx. Let me take the derivative. The derivative of u is du dx, but I'm going to multiply by that dx, get it onto the right-hand side. The derivative of 10x is just 10. The derivative of 3 is just 0. So instead of dividing by dx and multiplying it, I'm just going to write it like that with the dx on the right-hand side. Trying to get rid of 30 dx, I have 10 dx. Not good enough, so I'm going to multiply by 3, because 3 times 10 will give me the 30. This will allow me to give me 3 du equals 30 dx. That's what I'm going to substitute. 30 dx, I'm going to change to 3 du. So I'm going to make this the integral of u to the negative 1 times 3 du. Pass the 3 outside, and I get 3 times the integral of u to the negative 1 du. That's exactly the rule for the ln. If I had x to the negative 1 without a coefficient, it's an ln. U to the negative 1 is an ln of u. Then leave the coefficient, make this 3 times the natural log, pick up my absolute values from the formula. 3 times the natural log of the absolute value of u plus c. And then, not good enough to have a u, change the u back to 10x plus 3, and the absolute value sign works like a parenthesis, so I don't need an extra set of parentheses here. So we did a couple where you have to multiply. Let's do one now where we have to multiply by an integer. Let's do one where I have to multiply by a fraction, or a couple where I have to multiply by a fraction. So 26, let's do 25 together. I haven't done any odd numbered problems, and maybe it'll help you. Let's do 25. And when the font is small, this dot camera that I purchased for COVID times, it's not so great. For some reason, the school won't let me take the dot cam home that I use in my office to make videos. Not sure what the deal is there, but they won't let me use my office either. So anyways, it's a parentheses with an exponent. I wrote that parentheses with my exponent first. Anytime I have a parentheses with an exponent, 100% of the time, I let u be the inside of that parentheses. That's exactly what I'm doing here. That'll allow me to rewrite the problem. I can rewrite the problem as u to the 4th times 2x dx. So this 2x dx is what I need to get rid of using the derivative. I'm going to instead, well, let me just do it long ways. If you want to, I can go du dx equals to 8x plus 0. The derivative of 4x squared is 8x. The derivative of 5 is 0. I generally would not do this, and I would have probably written du equals 8x dx. Trying to replace a 2x dx. Well, to get an 8 to be a 2, I need to divide by 4, because 8 divided by 4 is 2. I'm going to multiply by 1/4, because multiplying by 1/4 is the same as dividing by 4, and it makes the integration easier than doing the division. So this is all my work to doctor up my u to get that match to happen. That stuff after the u needs to go away identically, and it wasn't ready to go away with the 8, needed to have a 2. To turn an 8 into a 2, I divide by 4, which is the same as multiplying by 1/4. So this will give me 1/4 du equals, those 4 and the 8 cancels, and I get a 2. So it's going to equal to exactly the 2x dx. So now I can rewrite the problem, and again, you might be able to skip some steps, but let me not skip steps here. So I'm going to keep the u to the 4th, and then instead of 2x dx, I'm going to write 1/4 du. Pass the 1/4 through the integral, and get 1/4 times the integral of u to the 5th du. That's a power rule. I'm going to add 1 to the exponent. The new exponent's going to be 6th. So that 1/4 that's out front, I'm going to need to multiply by 1/6, which is 1 over the new exponent. I get the plus c. Now I'm going to multiply these fractions and get 1 over 24. And I'm going to get rid of the u, put a parentheses where the u was, and what I let u equal to was 4x squared plus 5. That's going to go in my parentheses. So the answer to problem 25, which is actually one of your homework problems, would be 1/24 times 4x squared plus 5 to the 6 plus c. Let's do at least one more, maybe two more, where we need to divide, and maybe a more complicated one like 28, where I'm going to need to divide. 28, parentheses with an exponent, so let me rewrite it. Anytime I'm doing integration and I have a parentheses with an exponent, I like to have it written first. It's not absolutely necessary. If you could do some visualization in your head, this step is not 100% necessary. I just like doing it this way. I think it's easier to follow, and that's kind of my goal. Parentheses with exponents, I always let u be the inside of the parentheses with the exponent. That's going to allow me to rewrite the problem. How do I get to rewrite it? Well, this junk, instead of being that junk to the 5th, it's u to the 5th. And then I need to get rid of 4x plus 1. The dx kind of just works itself away. And in this case, let me do the derivative of u. I'm going to get du. I'm going to move the dx over to the other side. And because there's going to be two terms on the right-hand side, I'm going to put a parentheses. The derivative of 4x squared is 8x. The derivative of 2x is 2. The derivative of 7 is 0. I need to make this 8 into a 4, that 2 into a 1. 8 divided by 2 is 4. 2 divided by 2 is 1. So this divided by 2 is that. And instead of dividing by 2, I'm going to multiply by 1/2. And this is going to give me 1/2 du. And to do this junk here, I'm going to go 1/2 times 8x and 1/2 times 2. The 1/2 times 8x, the 2 and the 8 cancels, and you're left with a 4x. That's going to lead off my parentheses. And then the 1/2 times 2, those 2's cancel, and you're left with a 1. That's going to end my parentheses, followed by the dx. Now I have the perfect match that I need. So I'm going to rewrite the problem, and in place of that 4x plus 1 dx, I'm going to put 1/2 du. So I can rewrite this problem as u to the 5th times 1/2 du. This is going to be a general power rule, but I need to pass the 1/2 through the integral first. So I get 1/2 times u to the 5th du. Add 1 to the exponent, so my new exponent when I integrate is going to be 6, which means I need to multiply by 1/6 to do my multiplication and make the u into an x. The multiplication for the fraction is going to give me a 1/12. And then I'm going to change the u to 4x squared plus 2x minus 7. And that's perfect for my answer. Let's do one more that has an ln. And heck, let's just do 29. which is going to be your problem, and then we'll cut the video even though there's a problem or two that I'm not going to get to. So for 29, just in case it's not readable in that small font, it's 2 over 4x minus 7 dx. When I have a denominator with a binomial in it, it's generally an ln problem. This is going to be an ln problem. I made the denominator had an exponent of 1, and I'm going to create the negative exponent by moving the 4x minus 7 up to the numerator, making the negative exponent positive. I have a parentheses with an exponent. Anytime I have a parentheses with an exponent, I like to write the parentheses with the exponent first. Makes my life easier. -1 exponents, I know my answer is going to have an ln in it. Since I have a parentheses with an exponent, I always let u be the inside of the parentheses with the exponent. In this case, it's 4x minus 7. That will allow me to write the problem as the integral of u to the -1 times 2 dx. This is what I need to get rid of with this derivative. I'll do the derivative of u, and my du dx, I'm going to split the dx over to the right hand side. The derivative of 4x is 4, the derivative of minus 7 is 0, so I have 4 dx. I need to get 2 dx. To get a 4 into a 2, you need to divide by 2. Dividing by 2 is the same as multiplying by 1/2. So I'm going to multiply both sides by 1/2 and get 1/2 du. And then this side, 1/2 times 4 is going to give me 2. So I get 1/2 du equals to 2 dx. So this 2 dx, I'm going to replace with a 1/2 du and get the integral of u to the -1 times 1/2 du. Pass the 1/2 through the integral. I get 1/2 times the integral of u to the -1 du. And that's the special exponent. You can't add 1 to the exponent, divide by the new exponent because it's undefined. X to the -1 has that for its integral. U to the -1 is going to have a natural log as well. So when I integrate with a -1 exponent, you get a natural log. I don't know why I stuck a negative there. That should still be positive 1/2. And now I'm going to change the u to 4x minus 7. And my answer is going to be 1/2 times the natural log of the absolute value of 4x minus 7 plus c. So we'll call that the video. That's 33 minutes. That's a good stopping place. I skipped a couple, but I did a couple maybe on the front half that I wouldn't have done because those weren't from the lecture. So hopefully you've got enough that you get this done okay.